This is our last unit, Unit 4, logs and exponential functions, which is the most recent, so it should be the easiest for you, most remembered. All right, question 50. So here it's saying find the inverse of each function, prove the functions are inverses by composition. So remember that inverses is when x switches with a y. So f of x represents a y. So first I'm going to write it this way. Now remember, anytime you see a word inverse, you're going to understand that x becomes a y and y becomes an x, okay? Now, exponential, which is like 2 to the x or whatever, the inverse is a log. So anytime you have an exponential, you're going to end up with the word log. If you start with the word log, you're going to end up with exponential. If you start with an e, you're going to have a natural log, which is ln, Larry, Nancy. Anytime you have an ln, you're going to end with an e. They're inverses of each other, okay? All right, now, what you're going to look at is all you want is the exponent to be by itself. So I don't have anything added to the side or anything multiplied in the front. So what I am going to do is I'm ready to convert it into a log function. So remember that what holds exponent, it's called your base. Okay, so this is your base, this 2, it's your base. It's going to be a log, the base of 2. Now remember, in my class I taught my students that if 2 and y are together, right here, that means I cannot put y plus 1 here because then they're going to be together again. What I am putting is the other value or variable, which is x, okay? So this is going to be a log base 2 of x, and now equals the exponent, which is y plus 1. Okay. Now, lastly, you do want the inverse y function to y to be by itself. So the only thing you have to do is move the 1. Now, the key here is that when you have a log of base 2 of x, you do not put parentheses around the x and the -1 because the -1 does not belong to the log. It was moved after the log was created. So that's a very important. And what I mean by that is you cannot put it this way. Okay, so if you have a multiple choice like you guys had on your quiz or a test, this is wrong. This means that x minus 1, it's a part of the log. Okay, you move that -1 toward the end after the log was already created, so it's not a part of it. So you cannot put it. You could see written it this way as well, and that is okay too. Okay, when x belongs to the log and then 1 is after. Now, inverse function is always going to be written as y to -1 or f of x to -1. It's just a notation. It does not mean that you're doing anything with this -1 exponent. You're not putting it over 1 over the fraction. This just saying it's called, this represents an inverse function. Okay? All right, pause it if you need to write it down. All right, now question 51 again. This is a natural log function. So I'm going to change that to y right here first. G of x is a y of ln of 2x, and then outside, what does not belong to the natural log, it's -3. So first, we're going to change x and a y. Okay, now to change the ln into an e, because that's its inverse, I first need to get rid of that 3, because again, that 3 does not belong to that natural log. Now remember, you're not adding or subtracting anything or combining things, you're simply moving them around, rearranging it. Okay, so this is now going to be 2y. Now, ln is a natural log, it's by itself, so we can turn it into an e. Remember the ln's base, it's always e. It is assumed, it is never written. So now when you're turning it, just like you did with your log, you're going to say base first. Now, e right here and 2y cannot be together. So that means I cannot put 2y in here because then they're going to be together, right? So once again, ln of base of e raised to what's here, which is x plus 3, will equal 2y, okay? Now again, you want the y to end up being by itself, so the only thing to do is divide. Now, when do I know when to divide and subtract? There is a plus or a minus in between, then you add or subtract. Now here, there is nothing in between, and it's assuming it's a multiplication, so you're going to divide. So your final answer is going to be e raised to x plus 3, the entire thing divided by 2 equals y inverse. Okay? All right, pause that if you need to. All right, moving right along. All right, question 52. Again, it's assumed that this is my y, so I'm just going to change it to x log 5 of y. Now we're going backwards from log to an exponential, so I'm going to end with a number. Once again, there is nothing on the side, so I don't have to move anything or divide by anything or subtract or add. It has a log, base, and a body, so that means I'm ready to convert it. Again, you start with an exponent with the base as a starter. Now 5 and y are next to each other, so they cannot be next to each other here. So I got to use the x in here, and that equals y. Now you are done. There is nothing else that needs to be moved. Y it's by itself, and that is your inverse function. Now 53, x equals 2 log 4. You switch y and x. Okay. Now you do not touch the 3. The 3 is in a parenthesis here, belongs to the log. But what doesn't belong to the log is the 2. Now again, how do I know if I add, subtract, or divide? There is no plus or minus in between. That means I am multiplying, so the inverse operation of multiplication is division. So you're going to divide both sides by 2. This becomes now x over 2 equals, you got a log, your base is 4, and the body is y plus 3. Now a log is by itself, so you are ready to convert it into an exponential function. Again, your base is 4. You start with that. Now, once again, I'm going to repeat that y and 4 and y plus 3 are together. So that means I need to use what's on another side up here. So now 4 and y are not together. And of course, then I'm going to use the body. Now, y has a 3 attached to it, so to get rid of it and leave y by itself, again, there is a plus there. That's the difference between multiplication, as you guys having it here, and addition and subtraction. So then I am subtracting the 3. Okay, y by itself, that's an inverse. Now here, very important, the negative 3 goes to the side. Why? Because you already created y raised to x plus 2. You are moving the 3 to the side of that exponential function. Okay? All right, next question, 54. Solve each equation for indicated variable. You are solving for r. So the same principle, is just now has letters. So if you have an A, P, E, R, T, you're solving for T. Now I'm going to do side by side just to show you. Imagine that you have A equals 2 E R T, like this, okay? So what would you do here to leave the E by itself? Because E, it's an exponential function. You would divide it by 2, correct? Okay, we got to get rid of the P to leave the E by itself, okay? So now this side becomes A over P, and this side becomes E R T. This side becomes A over 2. Well, even if there was a number there, you would do that. And that becomes ERT. Now, once again, now ln is by itself, so guess what? You can turn it into an E. ln, base, it's E. Remember, it's assumed, but we don't write that. Now, again, E and RT are together right here. I don't want RT in here together with E again, so what I am going to use is the other side, which is A over 2 equals RT. Okay, the same thing I will do here. Here, I will do ln of E. Now, E and RT are here together, so what I do need to use is A over P. Okay, and that equals the exponent itself. Okay, now the only thing left, since we are solving for R, is to get rid of the T. So we would divide, because again, there is no plus or minus, by t, and then here we will divide by t as well, okay? So you will end up having a function that is r ln of e over ln. Again, we don't write the e actually. It's just assumed. But you would have ln of a over p, like this, over t. And again, the t goes underneath the entire thing. Okay, so that would be your solving for r. So pause that if you want to. All right, now go back to this one right here, the same principle. Okay, we are going to solve for b, which is a new exponent. So I got a 10bt equals c. So once again, we're solving for this. So that means we got to isolate the exponential function and then turn it into a log. Okay, so to do that, I got to get rid of this right here, which is a. And again, how do I know there's no plus or minus? So that means division. Okay, what's left? 10 to a bt equals c over a. Now, once again, this is an exponential function. Okay, so what we're going to do is we're going to turn it into a log. So my base, it's 10. So that means log base 10. Now, once again, same principle. This cannot be together here. So what I'm going to do is I'm going to get the c over a here equals the exponent. Now we're solving for b, so the only thing left is divide by t, which means the whole entire thing is divisible by t. So you are going to end up having a b that equals log base 10 of c over a divided by t. Okay? All right, question 56. Daniel invested a lump sum of money in savings account with a fixed annual interest of 5%. This is a compounding continuously after 7 years. The account balance reaches $5,676.27. How much was initially invested? Okay, so just want to remind you that there's 3 formulas. One, which is A equals your initial value. One, increase or decrease, rate, and time. Okay, now that's just when it's like a normal, straightforward, you given an amount, and then something is growing or decreasing, giving a rate and a time. In a sentence, you see a word compounded monthly. Either monthly, daily, quarterly, or weekly. Okay, that's when in the same formula, you're going to add your n. You're going to divide by n, and you're going to multiply by n. This is your n. Okay, so monthly is 12, daily is 365, quarterly it's 4, and weekly it's 52. Okay, so that means if in a sentence it says compounded daily, you're going to take and divide this by 365, and you're going to divide this by, and you're going to multiply this by 365. If it says quarterly, you're going to divide this by 4 and multiply this by 4 and so on. That is when it says compounded, and then it gives you either month, date, quarterly, or weekly. And then lastly, you have a formula where it says compounded continuously. That means it continues to go. And that is where formula, it's your final value, your initial value, E, and then rate and time. It's called PERT, P-E-R-T, PERT, okay? Again, write that down if you need to. Pause it. All right, so in our question right here, it says the word continuously, so I already know I'm going to use PERT. And this formula, it is not on your formula sheet during, final, so you do have to remember it. Another very important thing is that our rate always has to be turned into a decimal. So 5% is going to be 0.5. So remember that you're moving the dot to the left by 2. Okay, so here it says Daniel invested a lump of some money with this rate and compounding continuously after 7 years, the account balance reaches. So this is not your initial amount. You are looking for initial amount. This is your ending amount. So that's your A. Okay. So we are going to take this and plug it in here. Very important to read and make sure that you're reading it correctly. So that's 5,676.27. Now, your rate is given to you and your time is given to you. So your rate is 0.05% times 7 years. Okay. Now you're trying to figure out what is the initial amount. All right. So, what we can do is we can put this into a calculator. Okay. Again, E, it's a number. All right, so let's do that. So this was E raised to a 0.05 times 7. Okay, that gives you 7.36. 7.36. Okay, so this is 7.36p, 5,676.27 equals, and now of course you're solving for this p here, so all you have to do is divide both sides by 7.36. Okay, so again, I'm going to come up here and we're going to say 5,676 0.27 divided by all this. By E raised, I'm just putting it in a calculator this way to give me the actual times 7. Oh, you see how it dropped? Oh, okay. Okay, so the amount was wrong. Okay, very good point right here. I'm glad that it happened. You see how it dropped? The 7 dropped to the end? Okay, so originally, we should have put parentheses around it right here. And then multiply it for it to stay. Because sometimes the calculator like this, you know what I'm saying? So it would have been a different number. So actually, let's check it what the number would be. It would be 1.42. So 1.42. So I'm glad it happened. Make sure you're careful with that because it happens a lot also in Desmos. 1.42. 1.42. Okay. So now I can go back here and say, okay, and I can write it down in here and do 5,676.27. Oh, come on. 5,676.27 divided. I'm going to put E raised to 0.05 times 7. Okay, so that's 3,999. Okay, 3,999. So that's for question 56. I would round it up to 4,000. Okay, so that is saying that P, it's $4,000. So that means that he invested $4,000 and after 7 years with the percentage of 5%, he ended up having $5,676.27. Okay, sorry about that mess. All right, question 57 says the population of a town is growing exponentially. So word growing, it's important because that's a plus. And it can be modeled by this equation. Now the population is measured in thousands and time is measured in years since 1950. Approximately what was the population in 1960? So again, we do not know what was the population in this year. So we already given the equation f of t equals 42 e raised to 0.015 times t. Now, from 1950 to 1960, it's 10 years. So we are going to substitute this and put 10. And then we're simply going to put it into the calculator, okay? So this is, let me delete that. This is 42e raised to 0.015. And again, you have to put it in a parentheses for it to stay, and then times 10. Let's make sure that the percentage is correct. Yep. So it looks like 48 is the answer. 48.8. I would round it up. So 48.8 thousand. Okay. So f of t, it's 48.8 thousand people. Okay. All right, question 58. A marine biologist estimates the structure of a coral has a value of 1,200 cubic centimeters and that its value doubles each year. Write an equation of the form y equals a times b to the t, representing the relationship where t is time in the years since the coral was measured and y is the volume of a coral in a cubic centimeter. Using the your equation, determine the value of the coral 8 years later. Okay, so some of the information that we're given is 1,200 cubic feet and a word double. Okay, so that means that our equation will look like 1,200. That's your A, because that's what we're starting with the volume. And then double would be your B, which is 2. And then time is given to us by 8 years. And all really you have to do is put it into a calculator. So that's going to be 1,200 times 2 raised to the 8th. And your answer is 307,200. Okay. Okay. And then next question. All right. Question 59. A certain type of plant is growing in a pond in such a way that the number of plants are growing exponentially. The number of plants in the pond at time in months is modeled by this function. Select all the statements that are true about this function. Okay, so first of all, we got to graph this function. So let's go to regular Desmos and put this function in. And again, you can guys use a t, just make sure that you're putting n of t so Desmos knows how to read it. Okay, if not, you can also use an x. Okay, so 50 times 3 raised to a t. Okay, this way. So this is your function. Now, some of the questions that it's asking is to select all the statement. There was initially 50 lily plants in the pond. Well, looking at this function right here, this is your initial value. So this is a correct statement. Okay. The lily plant population tripled each month. Okay. So we can look at this statement and say, yes. Why? Because right here, this indicates the triple. Okay, so this is also a correct statement. Okay. C, the lily plant population decreases the number of months increase. So again, how do we know if the function is decreasing or increasing? If the number that holds the exponent, so number 3, if this number is more than 1, that means that it is increasing. If the number is less than 1, between 0 and 1, that means it's decreasing. So since this number is larger than 1, we're going to say that is not a true statement. It will have to be like a fraction type. Now we can also go and look our graph and see, okay, reading it left to right, this function is increasing, not decreasing, okay? So that is not a true statement. D, the number of lily plants will always range from 50 to infinity. That is also a true statement. It started at 50 and we do not know how much it's going to grow depending on the time. So it is a correct statement that we can go all the way to infinity. Okay. The minimum value of this lily is 3 lily plants. Well, that would not be a true statement because the minimum would be 50. There is no maximum value for this function. That is correct because again, depending on the time, this function, as you can see, it continues to go, 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 go. So it's just going to keep spreading and spreading and spreading. So that is a correct statement. Okay, next one. The n of 2 is 4050. So let's go, n of 2. So what does that mean? N of 2, that's like f of x, right? So they saying that when x is 2, the value of y is 4050. So again, when x is 2, well, that's not true because x is right here. Okay, so let's see. You would have to go all the way up to, what did they say? 4. No, that would not be true. 450. No, like right there, x value, even at 457, x value is 4, not 2, right? And of course, you can also plug it in and solve for it, right? You can do that as well. But no, this is not a true statement. And then the next one states the n of t is 1350 after 3 months. Okay, so we can plug in 3 months. Excuse me, we can plug in 3 months for our time. So let's check. So 53 to 3 months equals, and of course we can, and you can also read that off the graph as well. So 50 times 3 raised to 3 months. It's 1350. 1350, that is a correct statement. So remember, you plug in 3 months for t, okay? And then again, you could have calculated the other one as well, other than looking on the graph. You could have plugged in 2 months right here and see, so 53 squared, which is 50 times 9. And again, plug in and see, it's 450, not 4,000, okay? And then the last one, all real numbers is a reasonable domain for this scenario. Okay, that is not true because you can't have negative amount of plants growing, right? So the domain could not be all real numbers because we can't use negative numbers. So it would have to be everything that is greater than 0. Okay. And then the last one, J, there was 36,450 lily plants after 6 months. Again, we'll plug it in and put 6 in here and then plug it in into our graphing calculator. And 36,450, that matches the answer. So that is also a correct statement. So you got A, B, D, F, J, K. Okay? All right. Question 60. Mallory inherited land that was purchased for $30,000 in 1990. The value of the land increased by approximately 5% per year. What would be the approximate value of the land in the year 2030? So this one doesn't say a word compounded in any way. So your formula is just simply going to be P times 1 plus or minus. In this case, this is increased value, so plus, and then the rate in decimal. And then the time is so hold on. The Mallory inherited the land purchase. Okay, the time is from 1990 to 2030, which is 40 years. Okay, and then of course we would change the P right here to be 30,000. Okay, you will put all of this into a calculator. So it would be 30,000. 1 plus the rate, 0.05, and then raised to a 40. Okay? And you would get the amount of 211, 199.66. So 211, 200. Okay? You can just round it up to 200. All right. Dollars. All right, 61, an adult takes 400 milligrams of ibuprofen. Okay. Each hour, the amount of ibuprofen in the person's system decreases. So this word means a minus by about 29%. And how much ibuprofen left after 6 hours? So again, no other additional word of compounded in any kind of way. So we are going to start with 400. This is going to be 1 minus, very important decrease. The percentage is going to turn into 0.29 in a time at 6 hours. So once again, we'll go in here and we'll have 400 and then 1 minus 0.29 and then raised to 6 hours. 51.24. So 51.24. So started with 400. After 6 hours with this percentage of decrease, they will only have 51 grams. This is a G grams of ibuprofen left. Okay. All right. Now this 62, it's consider an exponential graph below. What is the asymptote for this function? So remember that you're always going to look for a flat line. And remember that exponential function, it's going to have a horizontal asymptote, and it looks like it's at -2, which means it's crossing y-axis. So that's going to be y equals -2. True or false, this function is negative for all the values that are less than 1. So remember, negative values, we're going to go ahead right here and find x-intercepts, where is 1. And that is a true statement, okay? All the values that are less than 1 are all underneath that x-axis. So that is a true statement. True. And then what is the range of this function? So remember that for the exponential function, domain is all real numbers, but range is going to go from your asymptote. So from here, and now where is the function? There is no function here, but where the function is above. So it's going this way. So that means we can say it is from -2, which is your asymptote, toward infinity. Okay, so this is your asymptote toward infinity. Now, parentheses will not be closed because the asymptote does not belong to that graph. The graph will never reach the asymptote. It will try to approach it, but it will never reach it. All right, question 63. 20 members of an invasive insect species were accidentally released into the forest. The population of the species grew continuously. So there goes a word continuously. Okay, increased 74% each month. Write an equation to represent the population of the insects after 4 months. So, of course, we got an A, that 20 members, so 20 even that it's written in words and not number. You got to pay attention. 20 members, that's what we start with, because again, continuously means part. So P-E-R-T, okay? So initial 20, and then E, rate 0.74, and then we don't know the time. So that would be our initial equation. Now B part says how many of the insects will inhabit for the forest after 6 months. So again, we're going to use the same equation that we just came up with. We start with 20, E, the rate was 0.74, and now time is 6. So we're going to put all of this into the calculator. So 20E raised, in a parenthesis, 0.74 times 6. And once again, I will highly suggest you use the parentheses. So 1,695, okay? So 1,695 insects, okay? After how many months will the forest contain 5,000? So after how many months? You solving for T, this is your end result. So this goes instead of the A. You still got 20E 0.74 T. Now you're solving for time. It says how many months. So again, you need to isolate the E by itself to turn it into ln. In that case, you got to divide by 20. This is going to cancel, so that's going to be 250. Okay, now E is by itself, you can turn it into ln. So that's going to be ln of base E. You can't have E in 0.74 T here. You want to put that number here, equals 0.74 T. And and now you're going to put, and you're going to solve for T, you got to divide by 0.74. Okay, so you're going to put all of this into the calculator. All of it. Now, I'm going to show you again how, and very important, you're going to put ln. You do not put the E down there because it's assumed. The computer already knows. And you're going to divide the entire thing. You do not, again, divide inside the parentheses. Okay, that is going to give you the wrong answer. Divide the whole thing by 0.74. So 7.46, so 7.5 months, because it asked you when, so time is 7.5 months, okay? All right, and then lastly, this one right here, to complete it, I'm just going to go one by one. You just use the calculator to do that, okay? I would not waste time to do it any other way unless you have to convert it, but if you are given an actual number, you can use the calculator to do that. And once again, I'm going to show you how to do that. I will use Desmos calculator right here. So the first one was log 10. So in this case, you do not use the log with A. You're going to use a regular log because the base is assumed to be 10. And in this particular equation, it was of 100. So the answer is 2. Okay. So that is x equals 2. Now, can you turn it into? Yes, you can do a base 10, which is assumed down there, raised to what's on the other side equals 100. And then you ask yourself, 10 to what power gives you 100, which is 2. Okay. All right, next question. Again, ln of E. Put it in here. ln of E. It's 1. So x equals 1. Next one, again, you could convert that because this is log 15 of 1. This is 10. 10 to 1 equals 15. Oops. X, not 1. I'm sorry. All right. 10 to what power of x equals 15? But once again, for safety and to make sure that you know what you're doing, and you're checking your answers, I would use Desmos on a final since it is given to you as a part of your resources, okay? So 1.176. Okay, and so on. You would go on again, ln of 36. I'm just going to give you answers for this one. You would just plug it in exactly the way it is. So 4 would be 3.58. Okay, now number 5, you do need to convert it before you put it into the calculator. So this one, it's 10 for question 5. This one, it's 10 to the x equals 64. So you can either figure out what power you need to raise 10 to get 64, or you can turn it into a log. Log base 10 of 64 equals x. So number. Now you're going to put that into a calculator, and you're going to get a 1.8. Okay. All right. So that's for 806 if you want to put it there. All right. Now the same thing for this one. You would turn it into a ln of e, which is not written, of 20 equals x. So again, you'll put that into the calculator, and it will be just ln of 20. Okay. You would not use the e. So that's 2.99. All right, next one, again, turn it into a log. Log base, which holds the exponent, is 5, of the number 23 equals x. And you would put that into the calculator, and you would get, for number 7, you would get x equals 1.948. Here, I don't know if you can see, I'm sure you can see it on your paper. This is a log 25. So this is a log base 25 of x equals 1/2. Again, you cannot put this in a calculator. You have to turn it into an exponential function. Base, it's what's on the bottom. You raise it to what's on the other side, because x and 25 cannot be together equals x. And you would put that in for number 8, and you will get 5. Okay. Next one, the same thing. This is a log base 3 of x equals 1. You cannot put that in a calculator. You have to do 3 to the 1 equals x. And that is just simply 3. And then lastly, the same thing. You would convert that 3 to the x, or, you can try to figure it out what it is, but 3 to the x equals 12. You would convert it into a log. Again, what holds the exponent goes on the bottom. These can't be together, so I cannot put x here. I'm going to put a 12 equals x. You put that in the calculator. And just to, because it's a different base, just to say that you would use log into the function with an a, which is this one, and you will put 3 of 12. And you will get 2.26. All right, so this concludes our final review. Again, if you have not got a chance to learn how to use Desmos to check some of your answers, please take time to do that, because these resources are going to be incredibly helpful.